there, I'm today just about to introduce you regarding universal laws of gravitation and its applications for the A-level students. Okay, let's move on to the video.
Hi there, have you ever thought that all the particles in the universe attract to each other in terms of gravitation? Yes, Sir Isaac Newton just discovered and formulated the universal law of gravity. And your secret crush, don't worry, you have at least the gravitational attraction with her even though he or she is not apparently attracted to you. Even with the beautiful aliens, you have attraction with them. According to the law of gravitation, as I mentioned earlier, any two particles can have the gravitational attraction of Fg. According to this diagram, m1 and m2, the separation of r. So the Fg is directly proportional to m1 and m2. Inversely is inversely proportional to the r to the power 2. So we can just formulate it like following. F is directly proportional to m1 times m2 divided by the r to the power 2 as according to this one. Now we have to put a gravitation constant g and the force is going to be fixed g m1 m2 over r to the power 2. Of universal gravitation states that force of two bodies is directly proportional to the masses and inversely proportional to the square of the distance between them. Gravitational constant g is a really smaller value 6.67 into 10 to the power minus 11 nm squared kg minus 2. So the gravitational force increases as the mass increases. So don't forget that you have a great deal of chance when your partner is really heavy. You have great attraction with you and the partner. The distance increases, the force decreases rapidly, so you have to maintain close distance with your partner.
I hope that you enjoyed the video and learned something from it. Now it's about to learn the speed of a satellite revolving around the planet, or the speed of the planet revolving around the sun, or something like that, anything. So according to the gravity, just move and watch it.
Very next important thing is the gravitational field intensity. What is the gravitational field intensity? According to the definition, force per unit mass is known as the gravitational field intensity. The field for the unit mass means 1 kilogram is equal to mg. That's the force acting on it. So when you keep it in the gravitational field, capital G, capital M over simple R square. So you can equal both two equations like mg is equal to G, capital M, simple M over R square. M and M can cancel off. So the gravitational field intensity becomes simple G is equal to capital G, capital M over R to the power 2. So for on the Earth surface, G is equal to capital G, capital M over R square. That is for on the Earth surface, and the radius of the Earth is the capital R. The next thing is you can just easily cross multiply an immediate equation and get the capital G M equals simple G R square. Remember, this equation is extremely important one in the future usage. The very new topic is the speed of a satellite. We know that a satellite is revolving around the Earth, and the Earth is revolving around the Sun. The Moon is revolving around the Earth. That's how it is, because it keeps moving in some periodic motion. So it has a condensed velocity of v and keep moving around a certain circular path, approximately nearly circular path. So we can solve this motion easily according to this animation. You can see the object is moving around a circular path. I just mentioned only in one cycle. There are so many revolutions. So that's a continuous tangential velocity, that of v, according to the motion. And the forces are just two forces. Fc is the centripetal force towards the center of the Earth, and that's maintained by the gravitational force, the law of gravitation. And there's a radius between the Earth and the stuff is with the r. That's not only belongs to the Earth only. Any object revolving around another, we can apply this in according to the gravitational law. And how to understand really important point, that is the stuff is maintained by two forces, the centripetal force and gravitational force together. These two forces are in balance. The gravitational force is capital G, capital M over simple R square, and the centripetal force is mv square over r. We can equal those two equations to equation 2 equals to equation 1, and simple m from both the equation can cancel off, then 1 r from each side. So the equation is going to be simple. So v is equals to square root g capital M over r. That's simple. Remember this equation. This is really important. This will be used again and again in future usages.
Hey, as you learned that, then the next step is to learn something like what? It's periodic time of the motion. Periodic time, yes. Yeah, periodic time. Time taken for one revolution. Using the same equation what we obtained previously, and the Kepler's rules, And this video is really exciting to know all of this and learn it. And
Very next important topic is the periodic time of a satellite. Motion of a satellite is not only for a satellite, it's for anything or revolving around any object. It's like the earth revolving around the sun, the moon revolving around the earth, anything can be. So the object can be revolving around the sun or anything. As mentioned in this animation like this, the satellite is revolving around the earth, within it keep revolving and revolving and revolving. So according to this circular path, the satellite has a tangential velocity that we mentioned in yellow color. So it's the tangential velocity. Angular motion is revolved in the other arrow bent one, so it's moving in a certain angular velocity as well. So that can be represented in the blue arrow. Now I mentioned in the curved one, so it just keep revolving around the earth with some periodic time. Now it's time to consider the time which begins with the time is equal to 0. That's the starting time. So the stuff is just begin to move now and keep moving with some constant velocity and comes to stop. It's not going to stop and keep moving. I'm just stopping it for the reference of to complete one cycle. Just the satellite takes some time. What is that time? Time is equals to the periodic time, right? It started from 0, now it's completed one cycle and came back to the initial position. The time is now periodic time. What is the periodic time? The time taken for complete one cycle in a rotational motion. So it's very simple to understand that now.
Considering the linear motion simple equation, v is equals to distance divided by time. Velocity is equal to distance divided by time. The distance is a full circle. The circle is the components of a circle is 2 pi r. Now applying to the equation, now it's going to get the simple equation like v equals to 2 pi r over capital T. Periodic time is the capital T. Now v is equal to gm over r, square root of gm over r. We just obtained in the previously. Just go back and see it now. So remember that v is equal to gm over r. And that's why I told you to remember this one. Now we can apply this v to the v of the previous yellow colored one. Now what is going to be the now velocity is going to be the square root of capital gm over simple r is equals to 2 pi r over t. Now just subject the t is equals to 2 pi r over square root capital G capital M over simple r. Now it looks really ugly. Now I rearrange the equation like this way. Capital T is equals to square root 4 pi r cube and over gm. Now I have to remove the square. Removing the roots, I can get it like the t square is equals to 4 pi square capital G m into r to the power cube. 4 pi squared over capital G m is constant for this equation because 4 pi is and capital G are universal constant. The mass is per constant per certain planet or the sun or something big object. So certain object, the t square is going to be proportional to the r to the power 3 because all of these constants are really constant middle terms. So the final equation that I can simplify it as capital T square is directly proportional to the r to the power 3. This is what something refers to the Kepler's law of gravitation. This equation is really important in solving MCQs.
as you learned that in this one, I'm just about to explain you regarding geostationary satellites. What is the geostationary satellite? I'm just going to explain you physically appearing. But when the earth is revolving around the sun itself, like it takes some 24 hours to complete one revolution. If you place a satellite, and you learned just now, satellites has a certain periodic rotational time. If we just place the satellite in a certain specific orbit, that takes exactly 24 hours to revolve around the earth. Now it's completely synchronized. That's why we call them another word, geosynchronized satellites. Both satellites, if you locate it on New Delhi or somewhere like that, Alabama, somewhere, so what happens, this satellite also rotate with the earth. So the both locations are not going to change over each other because the rotation of the earth is not going to change for billions of years from now. So it is going to locate on the same city where I just located. It's really important in communication if we use 3 geostationary satellites to cover the earth in all 360 directions. Now you can easily cover entire world using 3 satellites to communicate.
Very next point that we have to consider is the gravitational potential. What is gravitational potential? The amount of energy required to bring a unit mass from infinity to a certain point in a gravitational field. That is the definition. Remember that definition, and it's really important. In the papers you may have to write the answer for that. So let's consider the certain mass, bigger mass, that like of earth or sun or something. So you can keep the earth like at some distance of r away from the center of the object to bring it from the infinity. The path is really irrelevant. You can take any circular path, whatever, revolving few times around the object and come to there, or directly comes to there. So the energy is certain what scalar quantity, no needs to considered in the path. Somehow it should bring from that place, and the equation is Vp is equals to going to minus G capital M over simple R. For the A-level exam, you don't want to derive the equation. It's up to the university to derive the stuff. If you want to know the stuff, like I have uploaded previously in a certain shorts video regarding that. So this is really easy. Bringing a unit mass from the infinity, that means 1 kilogram mass. Remember this equation. The negative sign indicates the work was done by the system itself. That is why there is a negative sign. Now the very next point is the gravitational potential energy, the energy required to bring an object from infinity to a certain point in the gravitational field. In the previous time it was a unit mass. This is just another mass. It can be multiples of kilograms or fraction of kilogram. The mass is brought from the infinity to a certain point interest. So W equals to minus G capital M simple M over R. That is the equation to find out the energy. The same the thing that we found in the previous one, the negative sign applied in this one as well. The work was done by the system itself, nothing else. This is really important. The very next thing we can consider is the kinetic energy of a satellite. The satellite has a tangential velocity of v along the path, and the satellite is revolving around the earth. So the satellite is replaced in a certain point, so the stuff is revolving. So it contains kinetic energy as well as the potential energy according to the location as well. So the kinetic energy of the satellite can be represented by half mv square, and the velocity is nothing other than v is equals to square root capital Gm over simple r is the location of the radius. So we have to replace it, and the finally kinetic energy can be getting like capital G capital M simple M over 2r for the radius. The very next big thing is the total energy. Total energy is the potential energy and the kinetic energy all together according to the location and the speed satellite contains it. So the ET is equals to EK plus EP according to the equation. Now EK is going to be half mgm over r squared. This is the one we just recently derived, and the potential energy is equals to plus that with the minus gmm over r. Then finally we can just finalize the equation like so. The ET is equals to minus capital G simple M over 2 simple r. So if you have any confusion for the understanding how does this come, this is the way just we can get the capital G, capital M and simple M and R out of the equation as a common factor, and write half minus 1 for the equation. So now it is just easily solved out as minus half. Then the final equation is going to be ET is equals minus G capital M over 2r. This is also negative value. For sometimes you may get a question like certain raising a satellite to certain orbit, how the potential energy required. You can't just apply mgh because the radius is very bigger, so it's a big displacement. Gravitational field intensity is not constant, so the r is the radius for the earth and the h is the elevation you made to the orbit, so the orbital height from the center of the earth. So these are the two data you have. So use of these two data, you can just use it. Again, I am representing how does it revolve around the earth. It's revolving around the earth in a certain fixed path. So how to raise it from earth surface to up. So the first energy is minus G capital M simple M over R, and the W2 is the second location minus 2 G M M simple over H. So the W2 is greater than of W1. Now you can apply simply to the equation W equals W2 minus minus W1, so that is the energy difference. So because W1 is the W2 is the bigger, because why? In the W2 the radius is very high, the simple h is bigger than of capital R, so the numerator is denominator is bigger than the numerator, so the answer is getting smaller and smaller. So the for negative values, when you get smaller answer, that has the greatest integer value. So now we can apply to the W2 minus W1. W2 is minus G capital M simple M over H, and minus again G capital M simple M over R. So GMM over R just get out of the equation. Now it's going to be a minus half over H plus 1 over R. So finally you can get the equation W equals to G capital M simple M 1 over R minus 1 over H. Next very interesting here is the escape velocity, the minimum energy velocity requires to projectile object from the planet to certain get rid of the gravitational field is the definition. We have seen in cricket matches, baseball matches, football matches, the players hitting the ball and the ball reaches to some height and it returns to the ground. And if the player hits very hard, then it will still move very far long distance and comes down. If the player hits really extremely hard, the stuff is revolving, so moving out and still landing somewhere even out of the ground. So if the certain cannonball or something fired, still it will just come down to this stuff. Now if you fire extremely harder, it will revolve around the earth and just come down to the earth, still not fully get rid of the earth. So if you fire it with some minimum velocity, that is called as escape velocity VE, the stuff is not going to return to the earth, Earth is going to completely get rid of the system. So the stuff you can analyze in like this way: when you keep it on the earth's surface, the kinetic energy, you give some kinetic energy for the mass and it has a potential energy. So how to get rid of it? So the kinetic energy is equals to half mv square and the potential energy equals to minus G capital M over simple M over capital R is the stuff. The final energy is 0, so the initial energy should be equals to the final energy. So you can write T is equals to EK plus EP. So according to that, the T is according to Bloch conservation of energy, 0 equals to half mv square equals minus G capital M over capital R. So you can remove the M and M, both M's from the equation. The finalized equation is going to be V is equals to square root 2 capital G capital M over R. So we can apply capital GM by means of G simple R, capital R square. This is the one I told you to remember. Now once you apply that one, you can get the equation modified like V equals to square root 2G R square over capital R, then R and cancel off. Finally the equation becomes square root 2GR. So you have to remember these equations too, because both the equations are really important in applications. So don't forget to remember both the equations and all the way of derivations. Good luck.
Okay guys, I hope you enjoyed the video. Just like, comment, share and subscribe and hit the bell icon to get more updates future. Okay, thank you very much and God bless you.